Welcome back, ladies and gentlemen. This is going to be actually part 2 of our Enterprise MVVM series that we're going to be doing for WPF. And we're going to talk about adding a data and business layer, specifically using the Entity Framework ORM from Microsoft. And we're going to build on top of the existing application we did in the first session, where we covered some of the basics, such as building the view model and handling some complex data annotations, data validations using data annotations. So we're going to continue to use that project, build on top of it, move forward, and dive into some more complex scenarios that we need to solve through enterprise development. And this is really where a lot of people struggle. And what I want to say before I move into this whole thing is that there's many ways to skin a cat, especially with enterprise app development. But what I can say is that you should design for your current needs, keep it as simple as possible, but make sure you include within your design the ability to move forward and be a little bit flexible. Don't be too rigid. So we're going to go again through the deck of slides fairly quickly. The problem at hand is, how do you determine the right approach for your application? Most of the time, I would say that people often pick the most complicated approach, where they really need to start out very simple, because with the simple design, you can evolve that into something more complex as necessary. Yes, it takes a little bit of work to do that, but if you pick a too complicated design for what you're really trying to build, you can get yourself into a situation where you're not actually going to finish your application on time. You might not meet your budgets. You might actually find that you have so much complexity that you can't deal with it, and you don't want to corner yourself and put yourself in that position. So the other issue is, anytime we're dealing with layers and things like that, how do you avoid tight coupling with your view models and models? So the first approach we're going to take is going to have some fairly significant coupling, but it's still maintainable and manageable. But the reason this is a good choice to start with is because the application is so simple. As the application evolves into something more complex, you pick a less coupled, more flexible design. And again, the whole point of all this is to avoid high maintenance. And what we want to allow with this simple design, even though it might have some rigidness to it, we want to allow the data layer and business layers to be moved to a service off in the cloud if necessary later on. So basically, your business layer would be business as a service versus having a business layer inside a DLL that the client calls into. So we also need to be able to handle sync and async tasks, though in this specific session, we're going to focus on sync tasks. And then in a later session, we'll actually show you how to dive into async tasks to make your UI responsive and handle that in a good way. And we'll build on top of what's commonly known as the relay command, and we'll build a asynchronous relay command. And we also want to cover handling dependencies between the different projects and layers, because this also, anytime you're dealing with application architecture, that's part of it, is maintaining your project and not just the code itself. And overall application architecture. This is usually the death of a lot of enterprise applications, where they start to decay over time. They become really hard to add new features to. You start seeing a lot of bugs crop up, and usually that's because of either bad architectural decisions that were made early on, and as you've evolved your application, it's become to a point where it's so rigid you can't work with it, and that's what we want to avoid. So what we're going to start off with is a basic agenda. First we want to make sure we have the right project structure. So we're going to take the project structure we did in session 1, and we're going to migrate that to a enterprise structure. And I'll show you the enterprise structure that I've used and adapted over the years. And then we'll actually build a data layer using code first with Entity Framework 6, which you can get off NuGet from the package manager console. And we're going to build a unit of work business layer on top of our data layer that we'll call onto from our view models instead of using the data layer directly. And then we'll be working with an action command, which is out there called the relay command, but I felt action command was a more accurate name for that class. And then we'll utilize, again, like I said, our business layer from our view model. So to give you kind of an example of what this architecture will look like, and again, keep in mind, start simple and keep it simple, stupid. Keep those principles in mind. Don't over-architect. So this is not the exact architecture we're going to have, but it's going to be very, very close. This is just a mock-up that I did before we really started doing this series of videos and screencasts. But essentially, we're going to have kind of our, and let me see if I can get like a laser pointer or something here. So essentially, we're going to have our WPF desktop client, which is Enterprise MVVM.exe. And here you can see we still have our folders for views, we still have our folders for view models, and then of course most projects have the properties folder. And instead of users, we're going to be working with customer objects instead, so just some terminology difference. And then we'll have our Windows library, which we started building in session 1. So familiar things here. We have a view model, we have observable object, and action command, which we'll be building in this session. And then we have our data layer, which will be Enterprise MVVM.data.dll. And this will have our code first entity framework in there. So we'll have our DB context as well as our models. And then we'll have a business layer. And when we talk about layers in enterprise application architecture, a layer does not necessarily have to mean a physical boundary. It could mean we have a DLL, and within that DLL we have different namespaces. Namespaces are in of themselves layers. You can have different classes that represent different layers. So in our architecture, this is going to be a very simple layered system, but it'll be layered nonetheless. And this, we always talk about and have these discussions about in-tiered applications versus modern applications. Pretty much most modern applications are in-tiered, but in-tier used to be a specific set of architectural decisions in the past. So that's our deck of slides. We're going to move back into our demo project, and like I said, our first thing we're going to do is really start off by restructuring our project. So let's do that now. All right, so if you don't have the source code from session 1, you can go to the first session video that I did, and I put it up on YouTube, and you can go ahead and grab the source code from there. It's basically just a link to my SkyDrive. And what we're going to do is the first thing we need to do is restructure this into the proper project format, and fairly easy to do. So we're going to go through this fairly quickly. Basically, the project format is 5 different folders. We have a build folder, which is where a project output will go to. So these will be releasable binaries. We'll have a code folder for all the source code, and we'll actually go ahead and dump that in there real quick. We have a dependencies folder, which is very important. This is where we'll store third-party libraries like Entity Framework and things like that. We have a documents folder for documentation for the project, so anything that gets versioned. And then we also have a test folder for unit tests. So test projects specifically will be logically separated from the rest of the code base, but they'll still be part of the actual overall Visual Studio solution. So some basic things we need to do is we're going to rename this existing tests project folder in here, because we're going to add the existing unit test to 2 new unit test projects. And we're also going to create a desktop client folder. And we're going to move these 2 projects inside there. So enterprise.desktop client, enterprise.windows will both go in there. And we're going to open the solution. It's not going to be able to load a few of the projects because we moved things around, and that's fine. So we're going to have to re-add the projects, refactor some namespaces and things like that to get our project structure the way we want. So there's our nice little error message telling us we can't load some of the projects. Okay, so that's good. So in our solution, we're going to add the same solution folders. We're going to add desktop client as one solution folder, and then we're going to add another solution folder for tests. And we're going to take these 2 projects and move them in that desktop folder. And then we should, because they weren't loaded, we should be able to go to the properties window and actually specify where those projects are located. So we can go to our desktop folder, desktop client, and reload that project. And then we'll do the same thing for the Windows library. And just load that. And now we should be able to get rid of that guy and reload the projects. We may have to correct some references and things like that, but we can check and just double make sure. And so far so good. So we'll go ahead and minimize those. And we're actually going to remove this test project completely because we're going to add 2 new test projects. We're going to go to do that now and make sure if you're in Visual Studio 2010, make sure it's .NET 4. If you're in 2012, 4.5, and if you're in 2013, 4.5.1. Now, the location for these two test projects are actually going to be in our root test folder that we created. So these will be Enterprise MVVM.desktop client.test will be the naming convention that we'll use. And we'll do the same thing for the Windows library. And what we can do is just, let's nuke these existing unit test files in both those projects, and then we'll add the existing unit tests we had from our existing unit test project that we temporarily renamed. So we'll go over here to unit tests. So for the desktop client, we just want the customer view model. And we also want to add a reference to the desktop client and Windows projects. And we'll also add the existing unit tests for our Windows library. So code tests and observable object and view model tests. And before we go and fix up the references and change the namespaces, we're going to go up here to the properties for the desktop client. And we're going to go to all configurations under the build tab. And we're going to set the output directory for these to the build folder. And you could do it just for the desktop client and it'll carry over the library from enterprise.mvvm.windows. So we don't need to do it for absolutely everything. But if you want to be consistent, it's pretty much best to do that. But we will go to build, all configurations, and then we'll select our build folder. Okay, let's save those two. And then we'll go to our unit test project. And remember that we need to add a reference to system.componentModel.data annotations as well as our desktop client and Windows library for those specific tests. And then we also need to add the references for our Windows unit test project, which will just be Enterprise MVVM.windows. And and this will require the data annotations as well, actually. Okay, now we need to fix some namespaces. So we're actually going to go to customer view model tests first. And you'll notice that if you're using something like ReSharper, it'll actually tell you that this is wrong, but we're just going to make this consistent with the naming convention we use for the projects. So it'll be enterprise MVVM desktop client.tests.unit tests. And we actually need to create two new folders. We're going to do functional tests and unit tests. And then we'll move our customer view model tests into unit tests. And then you notice that we can, again, I'm using ReSharper, so it shows you dead code and redundancies. So we can actually eliminate some of this extra text in the import statements. And we're going to do the same thing for Enterprise MVVM.windows. We're going to create two new folders, one for functional tests, which is basically just another terminology for integration tests, and then we'll add our unit tests folder. And all of these at this point are unit tests. We'll move them in there. And then we need to fix up the namespaces for these as well. So it will be enterprise MVVM.windows.tests.unit tests and enterprise MVVM.windows.tests.unit tests for both those files. Okay, and we could get rid of some of the redundancies in those as well. Oops, too much. Okay, so let's close all these. And at this point, we can go out to the file system and delete the old test projects because we don't need that. So essentially, just a quick rundown, you should have a build folder, which when you compile your solution, and we'll do that just to make sure everything builds, and it does, you should have your binaries output to the build folder. So there's our desktop client. You should have your project, the solution file should be in the top level code directory itself. And then the actual projects will be categorized on our desktop client, and then their individual project folders. And then dependencies, which we don't have anything in yet, but make sure the folder is there. Same thing with documents. Tests, we can see our unit test projects, and we don't care about the build output for those. The point of this project structure is essentially, specifically for our code, we want to separate that between our tests, and having the tests in this folder allows test runners, especially things like Team Foundation Service, to find our unit tests quite a bit easier. Because I found in my experience that sometimes if you have a lot of unit test projects, sometimes they can have a hard time finding them if they're scattered all over the place. And if you use a good enough naming convention, you can make sure that you don't have any conflicts in names. Okay, so our project is restructured. So if you look in the Visual Studio aspect of it, you should have a similar thing where you have a test folder, desktop client, or two client binaries, and then we have our unit test projects in the test folders. So now we're at this point, we can actually do one last thing. We can look at our test explorer and see all of our unit tests, and we could run all these to make sure that we didn't break anything restructuring the project and make sure everything passes. And they do, so we can go ahead and move forward and start building our data layer and things like that. Now our data layer will be fairly straightforward for this particular session. So we're going to go back to our Solution Explorer, go to our desktop client. Because it's all going to be a client-based data layer at this point, we're going to add a new project. We're going to do a class library, and we'll do Enterprise MVVM.data. Go ahead and create that guy. And then we'll go ahead and add a unit test project for it as well. Now for the data layer, we don't need to write unit tests for things like Entity Framework. That's already unit tested by the Microsoft team that's working on that project. But you may want to test things like data annotations for your entities. You know, if I create a customer entity and I decorate it with a required attribute or a string length attribute, you may want to unit test those things to make sure that your business rules are clearly defined. Now what we're going to do is something a little bit different. So we're actually going to delete the, which we deleted the default unit test file out of that. We're going to do the majority of our tests as functional tests in our business layer. So for class 1, we're actually going to rename this to domain context. And we're going to go to our package manager console. Which is just up under Tools, Library, Package Manager console. And we're going to say, make sure you have the default project selected as Enterprise MVVM.data. And we're going to use NuGet.org as our package source. We're going to say install package entity framework. And we'll go ahead and let that install that into the project. So it's going to go out to NuGet, download the appropriate files, which you can see down in the status bar. It's downloading Entity Framework 6.0.2. Okay. Once we've got that, we're done with the package manager console, so we can just go ahead and nuke that window. So now you can see that it adds a packages.config, an app config, and it also adds a reference to Entity Framework. And if we open up this project in the File Explorer, you notice that in the root of our solution, we have a folder called Packages, and it has our Entity Framework library in there. So we're actually going to take, since this is a .NET 4.5 project, we're going to take these libraries, we're going to remove these out of here, and we're going to put those in our dependencies folder, like so. And then we're going to take these two references and do the same thing, just remove those, and we'll re-add the references from our dependencies folder. Okay, we'll add both those. Okay, and then we'll go ahead and delete the packages config. And we'll also go ahead and delete the packages folder out of the root of our project, which we'll probably have to do after we close the solution. Let's try and delete that one more time after we've saved it. So we'll go ahead and clean that up later. And what we actually forgot to do is this Enterprise MVVM library should actually be in the desktop client folder. So we'll unload our project in the solution real quick. Move that guy. Visual Studio still has that open. And then we'll actually remove the project and re-add it from that location. Okay, we'll fix up our NAD framework references real quick. Now, NAD Framework 6, I've not spent a whole lot of time understanding what changes they made after version 5 with the app config, but you'll notice that NAD Framework now has an additional library reference for NAD-framework.SQL Server, and they've also added support, I believe, for SQL Server Local DB, which is similar to SQL Server Compact Edition. And you'll have to read up on the differences between those as well. I've not spent a whole lot of time doing it. But again, we have some of the familiar stuff to us. We have our config sections, and they add the NAD framework section. We have now a default connection factory and a providers section, which I think is also similar to what we're used to in NAD Framework 5. Now, I'm not sure if all this is 100% necessary. We should ideally be able to remove it since we're just going to be connecting to SQL Server, which should be the default provider anyway. But we'll build that project. And then what we could do is something simple, actually. We could make sure that our data layer is able to create a database, for example, just to make sure that that works. So we'll create 2 new folders in our unit test project for our data library, functional tests and unit tests. And this will actually be a functional test because we're going to have a dependency on the database. And we're going to add a new unit test file in functional tests. We're going to call this database scenario tests. I'm just going to cheat, use our sharper to import that unit test namespace. And then we'll create a test method. It'll say public void can create database. And then we'll take our domain context we created. So we'll say var db equals new domain context. And then we'll do db database create database. Okay. And then we need to add a reference to our data library. So now we have access to our domain context. But now we can see that it's telling us we're not, it's not iDisposable, and that's because we haven't derived that from our DB context. So we're going to go to our library real quick and derive this from DB context. And it'll import that namespace for us. And we're also going to do some basic things. We're going to create a DB set of customer entities. Like so. And then what we'll do is we'll actually go ahead and create that customer class. And we'll create some basic properties on it. We'll do like create the primary key. We'll have first name, last name, and then let's also do email. And we'll just leave it that for now. It's just a very simple customer entity. So now we have a domain context with the DB set of customers. So now you can see we have, also we need to add reference to the entity libraries in our test project. So again, we'll go to browse, and we should be able to grab these from the recent folder in here. Oops, come on, let me resize. And here they are. Okay, and now we can use our database create method. So the other thing we need to do for this to work is we need to configure a connection string to a SQL server that we could test against. Now you can use any database server you want, whether it's SQL Server Local DB, you can use SQL Express, or you can use a full edition, even SQL Compact. What we're going to do for this is just use SQL Express because I have that database engine installed on this workstation, so it'll just be easy for us to do that. And we're going to go to the SQL Server Object Explorer, which if you're not familiar with, I believe you can go up to View and SQL Server Object Explorer. It's integrated in Visual Studio, and I think in Visual Studio 2012 they actually had a top level menu called SQL that you could access that through, if I remember correctly. I could be wrong. So once you're in here though, you can add a server basically to the list, which I already have mine added, but essentially it just asks you for the connection information. So I'm going to navigate down to my SQL Express server, and what I'm going to do is, we don't have any databases in there yet. So for this to work, we need a couple things. First, we need to add a connection string in our app config file so we know what to connect to. And then secondly, we need to also modify our domain context to be able to load that connection string. So we're going to do that part first. So we're going to go up to our domain context, and basically what we're going to do is we're going to add a default constructor, parameterless, and we're going to call the base constructor the DB context and say we want to look for a connection string called default in our application configuration file. And we'll just leave that constructor like so. We'll save our domain context, and now we'll go up to our app config in our data library, and we'll go ahead and add a connection strings section, and we'll add a new connection string, and we'll call this guy default. And then we'll say the provider name is system data SQL client, which is just a default provider that we have registered in our app config file. And then we're going to add the connection string. Now what we can do for this is we can go to our SQL Object Explorer, and we can select our server and then do View and Properties. And what this will give us is in our Properties window, let me drag that over here. Oops. We can go all the way up to the top and just grab the connection string from here. We'll close that, and then we'll paste that in here. And we don't need all of this. Like, we don't necessarily need a connection timeout, encrypt false, and trust server certificate. We can go a little bit more simple. And then we'll just add the initial catalog to this connection string. So we'll do initial catalog, and then we'll call this Enterprise MVVM underscore demo. And actually, let's do session 2. Okay, so now that we have our connection string, we'll close that out, and we will actually go to our Solution Explorer. We'll take that app config, and we actually want to move this really to the actual desktop client. So we can essentially take most of what's in this app config and basically add that to our app config in the desktop client. Let's make this a little bit more readable. Okay. And then what we'll do is we'll take this same app config, not necessarily the one from our desktop client because it has like the supported runtime, although we can. Let's delete the app config from the data library because we don't need that. And let's copy the one from our desktop client to our unit test project because it will need that to run our functional test. So let's close that and open the one up in our unit test project. Everything looks good. And then we'll go to our functional test and we'll go ahead and build our solution. And we'll go to our test explorer. And then let me make sure there's no database created, and we'll go ahead and run that functional test. Okay, and we can see that it passed. So now we should be able to refresh our SQL Explorer, and now we have our created database. So now we know that we have connectivity to the database server, which means we can go ahead and move forward with being able to write some additional tests as well as starting to write our data layer. Before we move on to creating the data layer though, we're going to do one more thing because obviously with this functional test, we don't want the database just to be hanging out there all the time. And we also don't necessarily want it to be the same database we're trying to use for the actual application. So what we're going to do is basically create a test cleanup method. And this will actually be a class cleanup. I apologize, class cleanup. So we want this to run after all of our database scenario tests have executed. And this method definition is just a standard definition for the Microsoft test runner that it expects. We don't necessarily need to use the context parameter. And then what we will do is we'll basically say using context. And then we really just want to delete the database if it exists. So we'll basically say if database exists, database delete. Okay. And then for the project itself, so let's actually delete the database we just created. In our Solution Explorer, we'll modify the app config for the unit test project specifically, and we'll do underscore database scenario tests will be the name of the database. So ideally when we run this test again, oops, I think I messed up the method definition. Method must be static, public, does not return a value, and should not take it. Okay, so we actually don't need a test context. I believe that's actually for the test cleanup and test initialize methods. So we'll remove that and rerun it. So we should get a pass. And our database basically should not exist, and it does not because it was cleaned up after the test was completed. Okay, so and we'll show you how to write better functional tests as we dive into more complex scenarios. We'll write a base class for functional tests. I'll do setup and teardown, but we'll get into that as we get into more sessions. So now we want to actually start designing our data layer now that we know we have functional database connectivity to the database engine. So to do that, we're going to go to our data test libraries, and we're going to start by actually building our business layer around our domain context. And if you remember a little bit earlier, we actually created our customer entity. So we have an ID with an email, first name, and last name. So we're going to go to unit tests under our data library. We're going to create a new unit test class. And we are going to, and actually this will be under functional tests, I apologize. And we are going to call this customer scenario tests. Okay, and again, we'll just mark it as a test class, make sure it's public so the test runner can find it, and we'll create a test method. And we'll do something simple like add new customer. And let's just kind of mock up some of the code we want to write. So we'll say using, and we're actually going to basically say that we have a business context that lives on top of our database context. So we'll say equals new business context, and we'll take a domain context as a parameter. So we'll basically actually say using domain context. And then we'll say that we want to be able to add a new customer. So we'll say BC, and let's actually say customer entity equals BC add new customer. And let's say to add a new customer that the things that we want to require are a first and last name. So we'll say, we'll just use my name as an example. And then our assertion will basically be is not null, and then we'll check our entity. And that'll be kind of our business layer. And what we'll actually do is this is really just going to make sure that the addition of the new customer is successful. So we'll say is successful. And you could even go as far as actually saying is persisted. Okay, so we know we need to do a couple things. We need to create a business context class that takes a domain context as a parameter. And actually we could just make this optional. So let's go ahead and nuke this guy because we really don't need to do that. We're going to say that our business context is a unit of work around our domain context. So we'll start by doing that. We'll go up to our data library and we'll go ahead and create a new class. And we'll call this business context. Again, make that guy public. And what we will do is we will seal this class because we don't want people essentially to get around the business rules. If they need to, they could go down to the data layer itself and use the domain context and not the business context. So we've created our business context class, and so we kind of get that constructed. It also needs to implement iDisposable, which is fine. So we're going to go ahead and do that. And the reason this is, and I'm going to cheat, I'm going to do Alt-Enter with ReSharper to write some of this code for me, but we'll actually implement the disposable pattern correctly. So the reason we're making it disposable is because we're going to wrap our domain context. So we're going to have a private read-only domain context that we will instantiate in our constructor. Okay. And we will implement our dispose pattern correctly. So we'll write dispose, pass in a true parameter, and then we'll suppress the finalizer for this object. And then we'll have a protected virtual void. And then we'll also have a private field to see if we're already disposed. And actually, it doesn't make sense to have a virtual dispose method when the class is sealed. So we'll basically say if disposed or we're not disposing, then we'll just return. Otherwise, we're going to say if our inner context is not null, let's dispose of that object. And we can actually make this private since we're in a sealed class. So there's our very easy disposable pattern. And then after we dispose of the context, we also need to say disposed equals true. Okay. So So now that we have our business context, now we need to add our first business method. So we can go back to that guy, and let's go ahead and hide our dispose code. And we'll do public customer, add new customer, and it takes a first name and last name as parameters. So pretty simple. So we have our method at this point, but we need to return and add the customer. So we're going to say basically context customers add, or actually let's do this. Let's do customer, and we'll say that the first name is equal to first name and last name is equal to last name. And then what we'll do is we'll say context customers add our instance, and then we'll also go ahead and save the changes. And then what we'll do is return the customer entity. And you could do a couple things. You could leave, in this case, we're going to go ahead and leave the customer attached to the inner context. And maybe later on what we'll do is dispose the context so that customers can be detached, or we can make a decision to detach customers when they're returned. But right now, we'll leave them attached to the inner context. Okay, so now what we can do is basically say, not only do we want to assert that the customer entity is not null, but let's go ahead and run this test first to make sure everything builds. So our test in its current state is not entirely accurate. So we're basically saying you're going to return us an entity. So if we actually debug this test, we can see that our entity is, of course, not null. And that's what we want. And we have an ID of 2, meaning that the customer was in fact created. And that's fine. But asserting that the entity is not null does not necessarily mean that it actually was persisted at the database, as our test implies. So we're going to actually do a remove the assertion for is not null, and we'll say bool exists equals BC data context, or actually in this case the domain context, which I think we'll refactor and rename to data context to make it a little bit more clear on which one is which. So bool exists equals our business context dot data context customers. And then we'll basically say any where the customer ID is equal to the entity ID. And then what we'll do is we'll say assert is true. And then the value of our exists property. So now we want to expose our data context. So let's go to this guy, and we'll basically add that as a property. It'll just be a read-only property, and we'll just return our inner context. So now we have access to that. Now we need to import system.link to have access to the link extension methods. And what we're going to do real quick is we're actually going to take this domain context and we're going to refactor and rename this to data context. And we'll do this manually. I'll avoid using resharper for this. So we'll rename our class itself. We'll also rename the file. And then we'll go to our database scenario tests and update this to data context. And And then same thing in our business context, we'll update all of these to data context as well. Okay. So now we should be able to build and rerun the test. And our test does pass, and we could debug this just to kind of take a look at what's going on in our code. And I want to point something out to you as soon as this breakpoint hits. And here we go. So our variable exists is set to true, which is what we expected because we added the customer, it got returned back. It was persisted to the database, and the entity IDs match. So we have an entity with an ID of 4, and the database contains an entity with an ID of 4, and that's what we expected. But if we're to look at this customer's database set and expand the results, children, well, we'll look in the database itself since the debugger can't seem to view that. Refresh. So we'll go to our customers table and we'll right click and say view data. We have many entities, and that's because part of our functional tests, we're not setting up and tearing down the database every time. So I'll show you how to do that next. And this is actually fairly easy. So first, let's close that guy out, shut down the debugger, close this test file, we'll close this file preview. Then we're actually going to go ahead and delete this database. Close all existing connections, and we're going to go to our test folder, and we're going to add another new project, and this will be a unit test project. And actually, let's cancel that. Let's keep it simple, and we will do right click on our unit test project, add new item, add a new class, and we'll call this functional test. And this will be a test class. Alt enter with ReSharper to import the namespace or type it out manually. And what we'll do is we'll take some of the code that we had in our database scenario tests, but instead we will have test initialize and we'll also have a test cleanup. And I believe to make these just virtual, and they don't need to be static because they'll be instantiated with the class when the test runner runs. And what we'll do is we'll take this code here and we'll say when we run a test, just to make sure, because tests can fail, check if the database exists, and if it does, delete it. And then once we've done that, basically say, let's add some brackets around this guy. We'll create our database. And then when we clean our test up, we'll do the same thing. We'll go ahead and tear down the database. So what this is going to allow us to do is for each of our functional tests, we'll set up a blank database. And then when the test is over with, we'll tear down that database so each test can be isolated so we can test the integration between the two pieces, both our code, our business layer, and the data store. So the downside about this approach is that, yes, we're creating and tearing down a database every time, but we're doing this on our local SQL Express instance, so it should be fairly quickly. And what I'll do is in a later session show you how to speed this up with a similar approach as we add more functional tests. But for now, this is simple enough and it meets our needs. So now what we can do is we can actually nuke this database scenario test. We're done with that guy because now we're forcing our other functional tests to integrate with the database. We'll know whether it succeeds or not. If we can't connect to the database, all of our functional tests will fail, which is fine, and it will tell us exactly what's wrong. So, but now we're going to take this test class and we're going to derive it from functional test. And what's going to happen essentially is we get that behavior. So we don't have to rewrite this in all of our functional test classes. We can just inherit from this class, and we'll get this behavior every time we have a functional test run. So what we can do is rebuild the project and rerun that test, and it should pass. Oops, that's because I've had the wrong signature again for test initialize. I can never seem to remember those method definitions. So we'll go back to our functional test, F12. Non-static public does not return a value. It should not take any parameters. So maybe it's just test cleanup, but I could be wrong on that one as well. Same thing. Okay, so now we can see that our test pass. We still have the same expected behavior because we didn't really change the functional test itself. But now if we go to our SQL Object Explorer and we refresh the database server, we can see that our database was torn back down. So we can rerun this test every time. So if we go back and run this a second time, but this time do it with a debugger breakpoint, we'll only basically have one entity record persisted in the database this time. So we'll let that break there. We'll refresh the database server. We'll go to our tables and we'll do view customer data. And there we go. We have just our one instance. So let's close that guy. And we'll go ahead and let that resume. And we can see that tore the database back down. So we're good to go. So now we can do a couple other things. Now we need some, basically, this would be a functional test. We're basically testing the integration between our business layer and the database, making sure that the record was persisted and that the primary key matches. And we could do some other things like make sure that the actual fields were persisted, but we won't go too in depth with that. But we also need to write some unit tests for this, which is why we categorize these separately. So we have some functional tests, but we also have unit tests. So this is going to allow us to test specific things like input parameters because we're not integrating with anything. So we need unit tests for this. And for this, we're actually going to go ahead and say business context tests, because unit tests more revolve around the individual methods and the most granular level of isolation you can get. So this would be a public test class. Again, Alt Enter with ReSharper or manually type that out. We're going to have a test method. And we're basically going to say add new customer, and we're going to say we have two parameters. One is first name and one is last name. And we're going to say throws exception when, and our scenario will be essentially when first name is null. Okay. So again, we'll create a business context. We'll basically say add new customer, and we'll pass on a null value for that, and then we'll pass in a last name. And our expectation is that an exception will be thrown. And we'll say type of argument null exception. And if we run that test, need to build the project for it to show up. It should fail because we haven't implemented that behavior. Of course, there we go, it failed. So now we can go to our business context and go ahead and implement that. We'll basically say if first name is null, throw new argument null exception. Okay. And we'll go ahead and pass in some parameters, and we'll say that the parameter name is first name, and we'll say first name must be non-null. Okay, now we'll go back, same thing, rerun the same test, and now we get a pass. Now we want to go a step further, and we want to say test method, same thing, expected exception, except this time it'll just be type of argument exception. And we'll say public void add new customer, throws exception, and we'll say when first name is empty. Same thing. So this time we'll pass in an empty string for first name. And we'll go ahead and run that test after building, and we should get a failure. And as you're writing these unit tests and functional tests, just keep remember the test term development pattern, red, green, refactor, and you'll be good to go. So now what we want to do is basically say if first name, or actually we'll do if string, and we could do either is null or white space, which we're already checking for the fact that it is not null. So we'll continue to use this, and we'll say first name, say throw new argument exception. And remember that argument exception, the parameters are backwards from argument null exception. So actually the message comes first, and we'll say first name must not be an empty string. And then the name of the parameter. And we can rerun our test. And now it passes. And we could continue to use the same pattern to continue and write unit tests for things like last name and any other type of parameter that we want to add to our business layer functions. So what this guarantees us is that these are essentially our business rules. We never want to allow a customer record in the database with a null or empty first name or a null or empty last name. Now in our case, we're just doing the first name, and we're going to move forward. But when the demo code is available after the session is uploaded, it'll have the unit tests for the last name as well. So we will go ahead and cut this session short here. We've, I think, gone a little bit over an hour, and we did most of what we set out to do for this session. We did create the correct project structure. We created our data layer using Code First and Entity Framework 6. We also created our small and simple unit of work business layer, which just has the ability to add a customer to the data store with a first and last name, and in this case we used SQL Server Express. So when we pick up in session 3, then we'll persist forward and show you how to create an action command, which is actually more related to MVVM itself, and then we'll actually utilize that business layer from our view model. And we'll have a couple different view models. If you remember, in our desktop client we had our customer view model that we worked with originally. We'll actually have a main view model for the window itself, and we'll have a mechanism that will allow us to create that customer, gather some input, and then create an instance of our customer view model that will wrap the newly created customer from our data store. So we'll show you how all that works in session 3. So I hope you enjoyed this session that we just went through. Like, subscribe, leave the comments if you have questions. I'm here. And then, like I said, the demo source code and the deck of slides will be available in the video description, as well as on my SkyDriver account. So thank you for watching, and we'll see you next time.